Math is a hard subject. There's no doubt about it. Like every year, lots of people do poorly in both high school and university level math. Regardless of the level of math you're in, you'd feel like it's a struggle, like at various points in your life. I wasn't really able to relate to this until I took Calc 3 and did pretty miserably in it. So I want to share with you guys four reasons why people do poorly in math. The first one is problem recognition. On tests, if you don't recognize a problem, you're screwed. You look at a problem, you don't recognize it, and it's like, the thing is, exams shouldn't involve any thinking, especially when you go to your university first, second, or third year. It's like 50 minutes is not a lot of time. You have to know exactly what you're doing. I can relate to this. I'll use Calc 3 mainly as an example, just because I've recently started reviewing it. So it's like on the midterm, my first midterm that I took back in 2018, I lost 10 marks out of 50, 20%, because I did not know the space curve parameterization. It was my first time seeing that type of problem on the test, so of course I didn't know what to do. Another time, I lost 10% of my grade on the final exam because I didn't really know the change of variables. I went up to my professor and I'm like, this question is impossible to solve. He's like, impossible? Did you not do change of variables? I was like, oh, that was my first time seeing it. So yeah, problem recognition is a big thing. If you don't recognize the problem, you're toast. Not just it's like with math. Yeah. The second reason is foundation, your level of foundation. If you notice, Eastern Europeans and Chinese people, no, I'm not Chinese, Eastern Europeans and Asians tend to do math significantly better than North Americans. It's a fact. It's not an opinion. You see their test scores and you wonder why. I mean, everyone's born the same way unless you had a birth defect, but even those with learning disabilities can perform well. So everyone's born the same way, including that exception. Why is that the case? Well, because for one, in China, like based on what my friends told me, they learn the math at a much faster rate. Like when you're in grade 7, you're already learning the quadratic formula. You're already learning sine squared theta plus cos squared theta. Sometimes you even learn that in grade 5, basically. Yeah, and it's like you have mountains of homework. Now, I'm not encouraging Canada to do this, but if you're looking at the facts, there it is. So then when they go to like, when I took Calculus 12 in high school, 80 to 90% of those students were like Asians and Eastern Europeans. And like, for example, my teacher, who is Bosnian, he told me something about the way he learned math. When like in elementary school, like you know that 6 times 5 is equals to 30, right? But have you ever wondered why? Well, because in Bosnia, at least the way my teacher did it, it's like they have to do 6 plus 6 plus 6 plus 6 plus 6 equals 30. In the US, they'd be like 6 times 5 is 30. They just reiterate the times tables. And then like you got it all, but like you should be able to instantly like this, figure out calculations, For me, I actually have a secret I've been holding on for a long time. My dad opposed me of sharing this secret in math, but I'm going to spill it out. I was taught by my uncle as like 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32, so on and so forth. By the age of 11, I was able to do 2 to the power of 26, which is, what was it? 67 million, 67108864, 67,108,864. Now I'm able to do 2 to the power of 30. I don't know beyond that. So it's like 2 to the power of 30 is 1073741824. You're asking me, what does this have to do with university math? But the thing is, I was able to get my foundation at such a young age so I could become very nimble and agile with numbers. So when the more powerful things came in, I was able to grasp it quicker than some students. Now I want to tell you why I did poorly in Calc 3. So it's like I averaged about a 50% on my midterms, and I only got 53 on the final. I got a B minus just because like the curve was low, but that wasn't me at my best at all. A part of it was because me slacking off and being addicted to games. But the other reason was I did not take linear algebra prior to taking Calc 3. So it's like in the course description, it even warned me. It said, warning, it is highly recommended that you take linear algebra either as a prerequisite or concurrently with calculus 3. So it's like I wasn't able to pick up the dot product and the cross product as fast as some of the students. And it's like in linear algebra, you learn the equation of a plane. Apparently, I had to work for that basically. So I learned slower. It didn't come as naturally to me. And the other thing is, it's like in university, you learn the stuff at a much faster pace than you do in elementary, middle, and high school. You're expected to know stuff really quickly. And it's like, if you fall behind, you're not able to do it. So it's like, for example, I wasn't able to catch up with change of variables, but it's like change of variables is actually not very hard looking in retrospect. But if you don't know double integrals, you're kind of screwed, essentially. I have an idea, like an opinion of a mastery of learning, not test scores, but I'm going to save that for the end of the video. Okay. So the, what was it? The third reason. There were a total of 4. Wait, let me be back. Hey guys, sorry about that. I had a bit of a brain fart. I was speaking faster than I was thinking. It'd be funny right now if I low-key just forgot what my ideas were. Actually, what were my ideas? No, Jinx. The third thing is impatience, basically. Homework, if you understand the material well enough, your homework should take no more than 3 to 5 hours 90% of the time. This is my experience I had when I've done well in my courses in both high school and university. It's like, so like as soon as I see a problem, I'm able to instantly do it. And if you've read, you sufficiently understood the material, the homework, like, it's like it might even be fun, basically, you know? So yeah, like people who tend to get answers on their homework often do poorly on tests. I've read this in an article and I've experienced it firsthand myself. It's not wrong to get help when you need it, but basically try the problem first, commit to the answer, then search up the correct answer online. And if you like do that, you'll be more likely to remember the answer. And if you, once you're done so, like basically try a few similar math problems yourself. I even provide like here, like, you know, problems on how to like on certain examples at the end of my videos, if you guys are patient enough, which I'm not optimistic since the 21st century people have the average lifespan of a goldfish. The fourth reason is an extrinsic reason. It's probably just something that's out of your control. I would say that 60%, no, that 80% of it was my fault in Calc 3, and that 20% of it was my professor's fault. My professor, I can't say his name, but like basically he was very unapproachable. For one, every time I raised my hand, he'd be like, yes. And he'd have a very angry look on his face, like, yes. It's like almost as if you're disturbing him and such. And like he was very, like he didn't want to help and such. I emailed him 6 times, one, two, three, four, five, six, a half of a dozen times throughout the whole semester. And I only got one reply at the end of the semester of him saying, you have to do this yourself. I was like, wow, thanks. That's a lot of help, you know? And like basically when I watched his solutions video, he doesn't go very much in detail, and his voice just sounds so bored. It's like a robot. It sounds like someone who hates their job. Like if you have the teachers like that in like elementary, middle, and high school, you would know. It's like just people who don't want to be there, or maybe their life was miserable as kids, so now it's their time to revenge us, essentially, thinking we're entitled millennials with like phones and all that. But I'm Gen Z, baby, so it doesn't apply to me. So these are the 4 reasons. Now, Khan Academy mentioned something about let's teach for mastery learning, not test scores. If you guys haven't seen the video, just type in the words Sal Khan TED Talk, and like it should be the first thing that pops up. I'm not going to play it here, but I'm just going to basically summarize. So basically, Sal Khan is saying that like people are not having a strong foundation. So what they want to do is like what he proposes is let's teach for mastery, not test scores. So it's like, let's say in elementary school, we're taking a current unit on exponents, we get some homework, and then eventually get a test. But then people have different like retentions and performances on that test. And then you move to more advanced things and you eventually find it harder to engage and such. So then he says, what if the students took as long as they could possibly take to master each subject, and then like, you know, they would do better and such. In a way, I kind of get what he's like saying. Like, I don't like discourage it, because like when I went back to do Calc 3 the second time, not take the course, but like relearn the material myself, everything made much more sense together. And like, I felt I wasn't constrained at that. Like I was able to get a more solid foundation in it. But however, I just don't think this idea is feasible. You know, like for one, self-learning takes a lot of passion and discipline. People who hate math for a living, they're not going to want to relearn the material by themselves. They're going to take the course and they're just going to be done with it, you know? Like this is especially common when I like took first year Calc 1 in the social sciences, which is one of the easier calculus courses. They're like, no, I'm done with math. I'm not going to self-learn it, essentially. So it's like you have to have a lot of passion. And I know there's some courses that offer where it's like you self-study, like you have about 4 months, you just self-study the material by yourself, and then you take a final exam at the end. But if you're not passionate or you don't have good like time management skills, you might push everything until the last week before you start studying, at which point you're going to say self-studying is just as bad, if not worse, than having an instructor teach it to you in such a constrained time budget. Plus, I don't think anyone would want to be learning math until they're 50 before they get a PhD, a piece of paper that looks like it was from a newspaper, so worthless that you could literally get the same copy on Google Images for less than 20 cents. So that's just my take on math. So yeah, also I forgot to not I forgot, but I wasn't able to post some practice problems for the midterm that I performed 2 days ago because the video primarily took too long. So I'm just gonna do that right now. Just give me a second to gather my sample questions and the answers, and I'll be right back. Hey guys, I just had to get my questions, my practice problems. So here they are. First one is 2 parts. Sorry about that. My thing is not writing. Sorry, what is going on? Let me figure this out. Hey guys, apparently I just had to plug it in somewhere else. So anyways, here are the practice problems, alas. So first one, prove the following limit exists. Prove that the limit of x and y going to 0 of 3xy squared over x squared plus y squared is equal to 0. And the hint is use squeeze theorem. Think about how I solved the other limit that equaled 0. Yeah, you should be able to figure this out. Let me know in the comment section if you have troubles with this. Use squeeze theorem. Prove that this limit does not exist. Wait, where is this? xy over 2x squared y plus y squared. DNE does not exist. The second one is about the directional derivative. So find the directional derivative, or dd, of f of x, y, z is equal to x squared z minus y over z squared for z bigger than 0. And the vector v is 1, 5, -2. And the point is 2, -3, 1. And this is, this is the point. And the answer is a scalar value, because the directional derivative is a scalar value, is, let me think. 8 over root 30. Wait, is it? Hang on. I'm getting a different answer here, sorry. It's 3 over root 30. Sorry about that. When you get it correctly. Part 3, question 3 is a maximum minimum question. It's once you get it, it's fairly routine. Find the critical points of x, f of xy is equal to x squared plus y squared minus 2x minus 6y plus 14. Find the CP. And when you get it, the answer is f of 1 over 1, 3 is 4. And this is a local minimum. It's also a global minimum, but you don't have to prove that. So basically just do what I did in the previous video. And yeah, these are the questions. Just to practice them. Let me know in the comment section if you have trouble on any of these. So that is all for today's video. Thank you very much for watching. I'd love to stay, but for now, I have to jump. I'll see you guys on the other side of the bridge. Catch you next time.